So the second type of cell that goes with a voltaic cell is what's called an electrolytic cell. Big part to focus on here is the prefix electro, okay, and what electro means is electricity. So an electrolytic cell is a little bit different than that of a voltaic cell in that it's not a spontaneous device. Still an electrochemical cell, but it doesn't happen spontaneous in regards to the activity on table J. So what it does is it converts electrical energy into chemical energy, uses a battery to force a redox reaction to take place. And we've utilized electrolytic cells in a couple different ways that we're going to talk about. The electrodes are inert, which means that they don't really do anything per se. They're just there to allow for a passageway of electrons. The anode is now positive, the cathode is now negative, and electrons still travel from the anode to the cathode though. So let's take a look at this. So you can see that I have my battery, and I have my anode, and I have my cathode. One example of electrolytic cells is electroplating. Looking at electroplating, you have the positive end, and why we call the anode positive is because it's hooked to the positive end of the battery. And we call the cathode the negative end in this case because it's hooked to the negative end of the battery. So what it does is it covers an object with a decorative metal. In this case, I have my electrons flowing, and my electron flows over to the cathode, and the anode is the metal, and the cathode is the object. And you can see here that the silver, in this case my anode, goes into an ion in solution. As it goes into an ion in solution, it is now free floating, and as it finds that electron on the cathode, it joins with the cathode, thus creating an electric plate of silver on the key. So again, it gives off that electron by being forced by the battery. The battery basically pulls that electron out of the anode, passes it on to the cathode by repulsion, so attraction and then repulsion, pushes it to the key. The key is now negatively charged because of that ion or that electron, and now the ion is attracted to that negative charge, thus causing an electroplate. We're going to watch a little video on that a little later. Second form, hydrolysis. Hydrolysis, prefix here is hydro, okay, so that's really our big focus here. And as you can see, really what hydrolysis is you're splitting water into hydrogen gas and oxygen gas. So by using a battery, I can actually decompose this water into hydrogen and oxygen gas. So the reaction, H2 is decomposed into H2O, sorry, is decomposed into H2 and O2. And our oxidation reaction, you can see that the oxygen is going from a -2 to a neutral charge. And our reduction, you can see our H from a +1 to that of a neutral charge. So still have oxidation and reduction, but by the force of the battery, now you're producing two different gases. The last form that we're going to talk about for electrolytic cells is that of electrolysis. So electrolysis is using electricity to break up compounds or apart. Usually we use this for salts or metals from group 1 and group 2. So most common way that we do this is we take a salt like NaCl and we break that up so that we can capture that group 1 metal. So if you were to use electrolysis to salt, you could actually acquire chlorine gas and that of sodium. So a reaction in this case, I have my NaCl producing Na and Cl2, so chlorine gas. The oxidation, well, lose electrons oxidation, so chlorine became negative and now neutral, so it lost 2 electrons. And now gain electrons reduction, sodium gained those electrons becoming neutral. So again, you're looking at the anode, in this case the oxidation still being forced out, okay, forcing those electrons away, so that would be the salt. And then the cathode, okay, in this case you're going to produce those free-floating ions in that solution. So again, you're having these pulled out and away, as you can see from your anode to your cathode. Really, let's look at comparisons to these. There's a lot of comparisons. Voltaic we know is spontaneous, where electrolytic is not. Voltaic have a salt bridge, an anode which is negative, a cathode which is positive. Remember, anode, A negative O. The cathode has the letter T, so it's positive. And electrons flow from the anode to the cathode, and we find this by table J. Anode and the cathode is actually acting as the battery. A voltaic cell is the battery itself. Electrolytic is a non-spontaneous reaction. It's converting electrical energy into chemical energy. It needs a power source, like a battery, and it forces the electrons toward the negative side, which is the cathode. In this case, the anode is positive, the cathode is negative, and we have three types of electrolytic cells: electroplating, hydrolysis, and electrolysis. Both of these involve redox reactions. Remember, anox, red cat. Ox means anode oxidized, reduction on the cathode, which is true for both. And both are electrochemical cells with electrons flowing from the anode to that of the cathode. Again, to summarize this a little bit different, outside of that, again, you're looking at the comparison of anodes to cathodes in the voltaic versus that of the electrolytic.